Due to its molten iron core, the Earth has a magnetic field around it, just like a bar magnet. This magnetic field extends outwards into space, forming a big bubble that we call the magnetosphere. The inner layer of the magnetosphere, from near the Earth's surface up to 1,000 or so kilometers, is called the ionosphere because it is made up of particles ionized via radiation from the sun. In low-frequency radio astronomy, when we point our telescopes to the sky to measure the faint signals that travel through space to reach us, we need to take structures and perturbations in the ionosphere into account that might change these signals. We need a good understanding of the effects of the ionosphere to make sense of our data. Pictured near the surface, the Earth's magnetic field lines run parallel and come out at an angle to the ground. It has long been postulated that tubular plasma structures go along the magnetic field lines, and it is structures like these that can affect our astronomical measurements. Previously, people could only guess what they might look like, since no one has ever been able to image them.
All of these spectacular happenings are visible manifestations of its existence. An electrical circuit that links the top of Earth's atmosphere, where charged particles are plentiful, to the Earth hundreds of miles below. Scientists at the University of Colorado, Penn State, and the National Center for Atmospheric Research are working to develop a scientific model of the processes across various spatial and time scales within the global circuit.
So one of the important aspects of this project is that there have been measurements taken about the electrical system for the last, 90 years, since 1930, for nearly a century. But there are no really good established models that allow one to verify the interpretation of those measurements and the physical pathways that lead to those measurements. Some of them have profound implications, but we need models to establish their credibility.
Sprites, elves, and blue jets, all shown on this mural, are collectively called transient luminous events, or TLEs, and are believed to be part of the global electric circuit. Red sprites, first verified in 1989, occur from cloud tops up to 95 kilometers, or approximately 10 to 60 miles, in the atmosphere directly above lightning strike activity occurring below. They last no more than a few milliseconds and can resemble carrot tops, columns, or jellyfish in shape. ELVs are large, expanding, donut-shaped luminous events, up to 190 miles or 300 kilometers across, that occur for only 1,000th of a second. They too occur over lightning activity, but are believed to result when an energetic electromagnetic pulse propagates from lightning into an area of the atmosphere called the ionosphere. It's brimming with electrically charged particles and at times auroras. It extends from about 35 to more than 1,000 miles in the upper atmosphere. Lastly, blue jets emerge from the top of thunderclouds, then fan out and disappear after about 1/10 of a second, at heights of approximately 40 to 50 kilometers or 20 to 30 miles. They are the only transient luminous event not directly associated with cloud-to-ground lightning. They were first documented in 1994. We have a lot more to learn about transient luminous events and their role in the global electric circuit. For that matter, we have a lot more to learn about the circuit's many contributors, from clouds to atmospheric particles and more. Scientists working at the frontiers of this science are leading the way.
We think that by pursuing an improved knowledge of the whole global electric system, that discoveries will emerge that we might not have even have anticipated. And that's the way basic research goes. It wouldn't be called basic research if we already knew what the outcome was going to be.
What is the cumulative effect of Earth's thunderstorms that charge the planet's electric circuit up through the ionosphere? What processes contribute to earthward current on clear weather days? What unknown roles might electricity play in our weather, our climate, and throughout our amazing, electrified atmosphere?